All right, we're back for another one. Today, we'll be looking at freestyle technique and breaking it down into parts so we can figure out where we make power and how we can improve our technique through research to make even more power and improve faster. According to research done by Raymond Cohen and colleagues in 2015, the contribution of your arms, which is your hand, your forearms, and your shoulders, contributes to around 85% to 90% of total thrust in the water. So 85% to 90% of what is moving you through the water comes from your hands, forearms, and shoulders. And so flipping that around, we can see that means that your kick will only provide you 15 to 10% of total thrust in the water. So then the question is this: what's the point of kick? What's the point of kick to move you through the water? If at all to move you through the water. The main purpose of kick is actually to stabilize your body and to provide your arms with the rhythm to continue stroking at whatever stroke rate you're doing. And so it's only after this primary purpose that the secondary purpose, which we know, is to provide you propulsion through the water. And to be honest, for me, for the longest time, I've always thought that the kick was to move you through the water, but turns out we've been wrong all along, according to what the research says. Getting into the freestyle stroke itself, on one side of the stroke cycle is the pull and setup phase, and the other side is the push phase. So I'll put it up on the screen. I drew a diagram here and I'll put it up. And so on one side is the pull, which is your initial catch section. And then the second part is your push, where you're pushing backwards on the water. And so really, when I've been coaching and even when I used to swim, I'd see some parts of the set which would say, for example, 3 200s freestyle pull. And so if you think about that and what we know right now, it's actually not pull, but push. So really it should be called 3 200s freestyle push, because the majority of the stroke cycle is in the push, and it can be seen by research, which we'll go through later, which says that majority of your power comes from the push section, not the pull. Another study from the University of it's a university in England. So that they found that in assessing several national and international level freestylers over 200 meter freestyle swims, that 8% of the stroke cycle was spent in the pull phase. So the initial catch was only 8% of the stroke phase, and 64%, which is an overwhelming majority, was spent in the push phase. And then 28% was spent in the recovery, where the arm comes over the water and into the glide. And it makes sense because the catch is the most disadvantaged part of your stroke, because you've got the least amount of leverage, right? Your shoulder is all the way back here where your hands are in front. And so at that point, you'd have the least amount of leverage to pull your body through the water. And so this catch phase is also the slowest point in your stroke, because your other arm will most likely be in recovery coming out of the water. And so there's not going to be that much leverage to make power. The same idea is explored in the same paper mentioned above from Raymond Cohen and colleagues. On the screen to my left, I'll put a useful graph which was produced in the paper. It graphs the force that is produced by each part of the stroke cycle against the stroke phase. So pull, push, and glide, where it can be seen that it's only after the catch phase that the peak force is generated in the water. And this is consistent over 6 strokes, so 3 on the left and 3 on the right. And because of this, it's only until you get into the push phase, where your hand crosses over the line of your shoulder, that you make the most thrust in the stroke. So what does that mean for you? This ratio of 8% pull, 64% push, and 28% recovery has also got to do with the race distance, which was done in the experiment. We can see that it was 200 meters of maximal effort. And so in that, we've got to think, all right, so in the shorter races where we apply this thinking, how long would we actually spend in the pull phase and the catch phase and the recovery? My thoughts are that during the sprints, you'd spend a lot less time in the catch phase because there's no point in gliding for a long time. The focus in a sprint race would be to make as much power as quick as you can. And so obviously the proportion of your catch would go a lot lower and the proportion of your push would go higher. Going into longer distance events like 800 and 1500 meter races, you want to spend more time in the catch and less time in the recovery. More time in the catch, more time in the pull, less time in the recovery. So the next time that you get in for a pull set with paddles and pull buoy, or even a normal swim, focus on the different phases of your stroke. You now know that in the pull phase, you won't make the peak of your power in the stroke. And you also know that in the push phase is the most powerful part of your stroke. And so to go the extra mile, you can start to think about what muscles you'll be using in the pull phase, what muscles you'll be using in the push phase, and train that accordingly in your land training sessions. And then so when you get back in the water, it'll be a lot easier for you to convert that strength from gym training into the water. Alrighty, so now we'll move on to the second part of this video and we'll talk about hand positioning here. So what hand positions in different stroke phases will give you the best kind of ability to produce propulsion in the water. When we were taught to swim, hand positioning was quite straightforward. From my learning, I was always taught that the best hand position to have was to have firm strength in the hands, like a good handshake firmness, and to have all the fingers close together. But of course, you don't want any water to slip through, and that's kind of the reasoning behind having the hands close together. But through doing research on the internet, lots of research, and reading through many journal articles, I've found that different hand spread angles produce different amounts of drag in the water, depending on which phase of the stroke you're in. So whether you're in the glide, the pull, or the push, different hand positions create different levels of drag. So what this means is that one hand position will be best for the pull phase and another hand position will be better for the push phase. This idea is clearly represented in a study from V.R. Mantha and colleagues, and they used CFD, which is computer fluid dynamics, which is a computer simulation of the water basically, to understand how the hand affects propulsive ability. What they did was test different hand configurations during 3 separate stroke phases. So the pull, the push, and the glide. Through this, they found some interesting results, which can be seen in this graph I'll put up on the screen. Here we can see that different hand positions generate different levels of drag force, which is important to consider because drag is what slows you down and drag is what also improves your propulsion. In the glide phase, where we want to minimize drag, the papers found that the hand adducted position is the most efficient because it produces the least amount of drag. So hand adducted is basically just tight together. In the pull phase, surprisingly, which note that from the previous part in the video, doesn't generate the most propulsion in the stroke, the hand adducted position also generates the most amount of force. Finally, in the push phase, which we found produces the most amount of propulsion in the stroke cycle of freestyle, we found that hand spread like this, around 10 degrees out per finger, generates the most drag, which is kind of what it looks like when you're resting your hand naturally. The reason why hands spread slightly apart produces more drag is because of this thing called eddies, which is produced in the water. To explain this simply, water is not difficult to move through when it's still, because it isn't moving all over the place. But water that is moving around a lot has a lot of energy that's causing it to move around. And so if you think about this on a really small level, the water passes through the gaps in your hand and it creates a lot of movement, which creates more drag on the back of your hand. More drag means that when you pull through the water, you produce more propulsion. That's why when you're in the push phase, it could help when you open your hand slightly and create gaps between your fingers to let the water through, but with more turbulence, which causes more drag. A similar study from Nicholas Sidelnik and colleagues also concluded that a 10-degree finger spread creates more drag force than having your hands together, which is 0 degrees of finger spread. And I'll put that up as an article right here. As we're at the end of this video now, we'll go through a drill to practice this technique. What you could do is essentially break down your stroke cycle into 3 parts, or 4 parts really. It'd be the glide, pull, push, and recovery, and just do the stroke part by part by part. Slow it down and do each part accordingly. Adjust your hands at the different parts of the stroke cycle accordingly. And then after a while, when you're confident with switching between the 2 adducted and spread, then you can start doing it more smoothly and faster until you're confident with implementing this type of improvement into your freestyle swimming. Remember, it won't go perfectly on the first try. It takes a lot of practice because it's a fine motor skill to open and close your fingers quickly as well. And so, look, if everything worked first try, everyone would do it and it wouldn't no longer be special at all. And so, yeah, just keep practicing and it should come naturally after you do lots and lots of practice, just as much as everything as well. Like, if you don't practice it, you're never going to get good at it. And that's even me speaking into this camera right now. The more I do it, the more comfortable I get. And so, yeah, basically, the more you do something you don't know, the more you'll know it, the better you get at it.